Assalamualaikum warahmatullahi wabarakatuh. We are from Group D4. Today, we will present to you Chapter 2 in Mathematical Logics and Proving Techniques under topics Logical Connective. There are 5 people in our group who are working together to complete this group project. Now, let's begin our discussion.
First and foremost, introduction. The following creative writing exercises are designed to equip students with the necessary skill to 1. Identify a statement or proposition is a declarative sentence that is either true or false but not proof. Number 2. Create true table depends on the true value of the original proposition. Number 3. Choose tautology, contradiction, or contingency based on the true value.
In this slide, I will explain about what is a statement. A statement or proposition is a declarative sentence that is either true or false but cannot be both. A primary statement can be denoted by any variable, but it usually denoted by letters P, Q, R, S, and so on. The truth or falsity of a statement is called its truth value. If the statement is true, the true value is the capital letter T or 1. But if the statement is false, its truth value is capital letter F or 0. Based on the example 1, we are analyzing different sentences to determine whether they qualify as statements and their truth values. For instance, UiTM is an university. It's a statement because it declares a fact, and its truth value is true. Similarly, the KLCC is located in Kuala Lumpur is also a statement, and the truth value is true. On the other hand, 3 times 3 equal to 6 is a statement, but its truth value is false because the correct answer is 9. Some sentences such as "Can you switch on the lamp please?" and "You are so beautiful" are not statements because they do not declare facts. They are instead a request or an expression.
Logical connectives. Combining two or more primary statements using logical connectives to form a compound statement. Each connective represents a specific type of relationship between statements. First, we have conjunction, and the symbol is the upside down V. We can read the statement as P and Q. Second, disjunction, and the symbol is V. We can read it as OR, such as P or Q. Third, conditional or implication, and the symbol is rightwards arrow. We read the statement as if P, then Q. Fourth, biconditional, and the symbol is left-right arrow. We can read the statement as P if and only if Q. Lastly, negation. Negation is not a logical connective, and we use to negate the statement. If the statement is true, it becomes false, and vice versa. In symbolic, not is written as shown on the slide or tile. We read it as not P. Next, conditional. We read the rightwards arrow as implies, such as P implies Q. P is called hypothesis, meanwhile Q is called conclusion. Other form P implies Q is not P or Q, or we call it as definition of implication. We have many ways to read P implies Q, such as if P then Q, Q if P, P is sufficient for Q, P is a sufficient condition for Q, P only if Q, Q is necessary for P, Q is a necessary condition for P, Q whenever P, or Q from P. Biconditional. As we know, we read biconditional by P if and only if Q. The other form is if P implies Q and Q implies P. The bracket is very important, so don't be careless. Biconditional statements show that two statements have exactly the same truth values or truth tables.
Now, let's move to primary and compound statement. We will use primary statements to form a compound statements. Like this question, we have two primary statements to form a compound statement. For this question, we have statement P and statement Q. Our statement P is, I don't see my advisor today. statement Q is I will see her tomorrow. Let's move to the question 1. We have P and Q. By using symbol N, our statements will be I don't see my advisor today and I will see her tomorrow. Next, question 2. We have P or Q. Using symbol OR, our statement will be I don't see my advisor today or I will see her tomorrow. Question 3 is a conditional statement. For conditional statement, P is a antecedent or hypothesis and Q is our conclusion. So, for question 3, P implies Q, our statements will be if I don't see my advisor today, then I will see her tomorrow. Next, question 4, we use symbol not and symbol implies. So, and the question is not P implies Q, then our statement will be it is not true that if I don't see my advisor today, then I will see her tomorrow. The last question is P, biconditional. The question is P if and only if Q. So our statement will be if I don't see my advisor today, if and only if I will see her tomorrow.
The third part of logical connective is truth value and truth table. The truth value is the truth or falsity of a statement or proposition. The second part, which is the truth table, is to display the relationship of the truth value of the statement. For truth table, we need to determine the number of variables. If the compound statement has 2 variables, we need 4 rows, while the compound statement was 4, we need to construct the table with 8 rows. In logical connective, there are some rules that we need to know. First rule is for conjunction. If statement P and Q is true, so the truth value is true, otherwise it's false. Second is disjunction. If statement P and Q is false, so the truth value is false, otherwise it's true. Third one is conditional. The truth value will be false if P is true and Q is false. For others, it will be true. The last one is biconditional. The truth value will be true if both statements P and Q have the same truth, but if they have the different truth value, it will be false. The last part in logical connective is tautology, contradiction, and contingency. A statement are called tautologies when all the truth value in the last column is true, and when we simplify it by using laws of logic, we will get T. For contradiction, we will get all the truth value in the last column is false, and we get F when we simplify. Last but not least is contingency. A statement are called contingency when in the last column it contains both true and false.
Next, for example 3, for statement P and Q, show that in bracket P and in bracket P implies Q is tautology. For the first column, P is 0011. For the second column, Q is 0101. For the third column, P implies Q is 1101. For the fourth column, P and in bracket P implies Q is 0001. For the fourth column, in bracket P and in bracket P implies Q equal to 1111. Since the true value for the last column equal to 1, so in bracket P and in bracket P implies Q is tautology.
In conclusion, a statement is a sentence that can be classified as either true or false. In propositional logic, symbols are used to represent the relationship between statements. These relationships are established using logical connectives such as conjunction and disjunction or negation, not, and conditional, if then. Logical connectives are essential in forming compound statements which consist of at least two individual statements.